Well, good afternoon, ladies and gentlemen. It's a great pleasure for me on behalf of FP-PIGMENTS to share a stage, to be honest, with the likes of Chemarc, Lanxess, BASF, and great chemical companies that have done fantastic things over the last 50 or 100 years. Before we do the technical presentation, I just want to introduce you all to FP-PIGMENTS because we're a company that's only been around for about 10 years. And as a result, our technology is very new, the company is very new, and I'm sure to all of you, our name is very new. So FP-PIGMENTS are, with respect to this meeting, a global manufacturer of opacity pigments that are essentially used to replace titanium dioxide. We have unique patented products. Our patent cover goes out for 14, 15 years now, and we're continuing to increase our technology and expand that patent cover. We supply into the coatings, plastics, and paper markets, as well as printing inks with our TiO2 replacement materials. And we're a global player. If you look at the map here, we're a Finnish company in Finland. Temperature's a lot lower than here, but the technology came out of there, our research laboratory and pilot plant is there, and our paint labs are also in Finland. We have a large manufacturing facility in Germany, just south of Berlin, and we also have another manufacturing facility in Rome, Georgia, in the United States, allowing us to supply all of the largest users of TiO2 with something else to reduce their costs without reducing their performance. But FP aren't just a small company making a new pigment product. We actually have 4 parts of our company. The other parts probably aren't as relevant to the group that are here, but it's important to understand the kind of the pedigree and the growth that FP have developed over the last 10 or 15 years. You know, we have a chemical trading arm called Chemarc, and we also have a polymer business called CH Polymers, based in Finland, which is where our paint lab is, and we have a lot of shared resources with these guys, which means that when developing our technical solutions, we have a lot of cross-fertilization of ideas and of, and of final solutions. We also have a new business, which we like to talk about because it's called CH Bioforce, where we're developing, again, new 21st century technologies, here looking to develop polymer products, basically from trees, using biomass to make polymers, to make various things that are going into plastics, coatings, composites in Finland. The whole ethos of FP, or of the group, is about 21st century technology moving forward into an era where we have to use less carbon, we have to do more with our technology to make more of, to make more of everything in the world around us. So that's enough about the company. We're here to have a technical presentation. My colleague Smita Shilar is going to talk to you about the FP-PIGMENT titanium dioxide replacement product, and then when she is finished, I'll come back and talk a little bit about the commercial benefits it ought to impart to you guys in the final market.
Thanks, Andy. So let's see about the product. FP-PIGMENTS, it's a composite product which is made to use the replacement of TiO2, partial replacement of TiO2, while maintaining the optical and performance properties, and it gives you a cost benefit also. So if you see, this is the diagrammatic representation. The big round particle is FP particle. How it does the job of TiO2 replacement? We have few TiO2 particles inside the big particle, and it has ultra pure calcium carbonate shell. So you can say it's an encapsulated TiO2, which is meant to enhance the properties. Then it gives spacing of TiO2, which improves light scattering. It creates air voids to maximize refractive index differences. And it increases light scattering as a result of its irregular surface structure. So its refractive index is 1.9, which is in the range of pigments refractive index. Okay. Now this is a small representation how the particle is made. This is, first we take TiO2 slurry, which is dispersed at very high shear, and then we precipitate calcium carbonate onto it by making it in situ using lime and carbon dioxide, and then this particle is made. This is how exactly it looks. It's a scanning electron micrograph of FP pigment. Now let's come to the specific application. FP-550 is the grade which is meant for polyolefin masterbatch. It is designed for this specific application. It is easy to use, works in any other extenders and fillers which are already in the formulation. It partially replaces TiO2 while retaining the properties. And it's applicable in variety of end-use applications like blown film, injection molded articles, agricultural films, color plastics, vacuum formed articles. So basically covering variety of applications. Now let's have a look at few results which we have done. This is the opacity. Just to give some background, it is 60% masterbatch, which let down at 5%, 50 microns film thickness, and contrast ratio is measured as per the standard method. And if you see the second column, that's the standard. It's 3% TiO2. And if you just replace 10% TiO2 without anything, you see this effect. There is a drop in opacity, and if that 10% is managed with FP-550, then you see it is matching with the standard. And the next column shows 15% replacement of TiO2. It has also similar opacity, you can say. So successfully it is replaced by 15%, you can say. Now this is about FPV. That's 60% TiO2. And if it is 10% replaced, it is just reduced 10% in first case. It is not replaced. And the last one is 550, replaced 10% replaced with 550, which is well within the acceptable limits of FPV. The big column is, this is for our earlier version of FP, which is we have improved to give good FPV. So 550 performs well. Now this is about the brightness, color retention. It's again, you can see, this is the standard one. This is 10% replaced, 10% reduced, not replaced with anything. And the last one is 10% replaced with FP-550 and shows similar results. Now this is very interesting slide. This is colorant reduction in tinted system. That means if you have a standard, which is a tinted one, and if you replace 10% TiO2 with FP-550, you will get a little darker shade, which means you have a scope to reduce some colorant also from your formulation. So here it is 2.5% colorant reduced after you have replaced 10% TiO2. So you have a scope to replace colorant and TiO2 both. So if you compare slide number 1, the sample number 1 and the sample number 5, in which you have actually replaced 10% TiO2 and 10% colorant to match the exact shade. So you have a double savings. Now, this is about the thin films. The background of this testing is reference 60% TiO2. Masterbatches taken, 8% and 12% TiO2 replaced by FP-550. And then blown films are produced by letting down at 2%. And 50, 25, and 10 micron film thickness is made. And if you see here, this is the color retention. This is 10 micron thickness. The standard 8% replaced and 10% replaced, 12% replaced. And this is 25 microns thickness. And again, the same sequence of replacement, standard 8%, 12%. And this is 50 microns. You can see the color is retained more or less, almost comparable everywhere. And in the next graph, if you see, this is about the opacity. In the same sequence of standard, 8% replaced and 12% replaced, you can see the opacity is also maintained. So the conclusion, you can see almost 12% of TiO2 replacement is possible in case of thin films. So benefits with FP pigments, saving money and saving the environment. So improved opacity efficiency, optimized TiO2 uses, reduced colored pigment uses, and environment, lower carbon footprint, reduced CO2 emissions, and efficient water uses. I'll just try to explain this. This is about the green values we offer. So our product's carbon footprint is approximately 75% lower than TiO2. Reduce CO2 emissions. CO2 is our raw material. We need to use CO2. Okay, so we don't emit it. So we preserve our environment. So reduced water uses. We have a closed water circulation and we reuse water. And higher solar reflectivity. Our product absorbs less heat and keeps the surrounding cooler. So this is worth mentioning here. So I invite Andy once again to talk about commercial value.
When you're selling a titanium dioxide replacement product, the nature of the titanium dioxide market is always going to determine the customer's interest or willingness to want to replace the TiO2. At the end of the day, no change when TiO2 is cheap is generally the best thing for your business. Those of you who buy a lot of titanium dioxide will subscribe to all of the places and sources of this information, so you'll probably have seen it anyway. I thought, in the light of essentially what we're seeing happen with our product in the world over the last 12 to 18 months, it's worth just a very brief review of where we are with the titanium dioxide market. All of you will have seen prices rise. Many of you will have seen material less available than it has been in the past. And that's probably going to continue well into next year. And even then, whilst the TiO2 market is these days effectively a commodity market, there isn't going to be the investment. I can say this without being a TiO2 producer. There isn't going to be the investment to make the price drop down to where it was in 2014. So TiO2 prices are probably going to stay high for a while, which basically means that a product like ours is a decent investment when you think about what you're going to get over the medium term for what probably is going to have to be some upfront technical work in order to get it into the factory, have another SKU around, introduce it into the formulations, and if you want to take the tinter savings, redo your colors. We understand it's extra work. So one of the things that we've worked with largely elsewhere in the world, in America and in Europe, where we've had significant success with selling FP, especially in the last 2 or 3 years, is we like to try and help them to understand about what the cost savings can be. Okay? So essentially, our product retails at in this TO2 market price now, somewhere around about $1,000 a tonne less than TO2. Depends what price you're paying for TO2, big user, small user. But effectively, when you're looking at it in dollar terms, if you're going to be a 100-ton replacement of FP, you're probably going to save $140,000 a year. Okay? Don't think about it as a 10% replacement. Think about it as how much TO2 you're not buying. Even a 5% replacement can work in a number of different formulations. If you're a 500-ton user of FP, the savings can be very significant. And I just converted that last number into Indian currency. Okay? But even then, it's not just about the price difference. Because FP is a different product. It isn't TO2. It contains TO2. It's not an extender because it contains TO2. It's a highly engineered product. It's 21st century technology that, as high technology, is actually being sold for a lower price than the existing technology. And that's what makes it so interesting. But in order to help our customers understand, I don't want to spend too much time on these other slides, but you'll see this is an active spreadsheet program that we use with our customers. That if a customer wants to come and see us and they want to do a cost evaluation because they want to show it to their production manager or their finance manager to justify the work they need to do, we can help them build a business case for that. And so essentially, here's just a scenario. You're looking over 5 years to replace your titanium dioxide. Let's say this is a medium-sized master batch user that's buying about 2,000 tons of TO2. For argument's sake, can I go back with this one? How do I go back? Yeah. For argument's sake, let's say they're currently buying at $2,900, which is probably where ICIS say the price is, okay? The FP price is probably around about $1,500. Our price varies a little bit, but at the moment, that's probably roughly where we are. So when you look, this little thing here, year one, we're talking about $2,900. Year two, let's assume that the TO2 price falls, and you guys are all going to get a little bit happier. $2,800, $2,600, and maybe even the unlikely scenario of less than $2,000 a ton. Okay? We have in here also a cost of the reformulation work you're going to do. And we're assuming that you get a 10% replacement, but you only do it in 50% of your formulations, which is fair enough. Okay? You're actually then going to become a buyer of 100 tons of FP. When you look at that scenario across the 5 years, there is always a saving with FP, even at the lowest TO2 price. So when you do the work to introduce FP into your product, you're building a hedge into your future purchasing that will mitigate future rises and falls of TO2. Saving this year will be good. Saving next year might be a little less. But you're never going to make a loss. You're never going to need to do the work to take it out again. Okay? Because our product contains TO2. And the TO2 price goes down, our cost goes down as well. Okay? So when you look at the final like business case sheet for this, and this is the same calculation. Oh, sorry, pressing the wrong button. In that first year, you'll save $140,000. But you'll also, if you think about it, have reduced the cost of your inventory by that 100 tons times the reduced price of FP. So you have a hit on your profit and loss in that first year of another $50,000, okay? Which is a big benefit when the TO2 price is really high. In those other years, when the price is falling, you're still going to get a saving. But when you're trying to decide if you want to spend this, let's call it $50,000 to do the work, maybe put in a different dosing machine or something like that because you've got to introduce another raw material, which is difficult sometimes. The 5-year total saving on only a 100-ton replacement is $500,000. If you take 10% as a working cost of capital, the net present value of the project is nearly $3.5 million, and the rate of return is 340%. If you show this to your finance manager, he'll want to know why we're not doing it. Okay? So, using FP, it's not a commodity raw material that's just cheaper. It's like a project. It's like having a new piece of equipment or even a new IT system that just saves you money. And essentially, that's our message. It was interesting to hear the comment earlier about TiO2 replacement being like gold-plated. Many of them are. I completely agree with you. But what FP is like a Fabergé-engineered piece of jewelry. It's 21st century technology. It's not a cheap blend of low-quality raw materials. The technology we use to get that TiO2 perfectly spaced optically, which you cannot guarantee with existing TiO2 because it's dependent on the formulator. The technology we use, we're selling to you at a lot lower price. So that's everything we have to say. If there are any questions, we're happy to take them if we have time. And I'll just leave the last slide up, which has some of our contact details on, if anybody has anything they wish to ask.
Thanks, Andy, for a very informative presentation. There are two concerns. I'm Siddharth Doshi from Ray Colors. We make Masterbatches. There are two concerns. First is that slide, if you can just help me to get that slide of the color concentration, the saving on the color. The five, yeah, this one. Thank you. Now, in this, when you make a chip or a swatch, the thickness matters when it is titanium dioxide or like any tintorial strength when you are measuring. So when you reduce the color, it is obvious that you have to reduce the whiteness to maintain the same kind of tint tone or shade. So whether it is a saving or not is to be judged when you genuinely reduce the thickness of the film, then you will be able to see the color strength. Otherwise, in the thickness, when it is completely opaque, it is very difficult to judge the color strength. When you reduce the pigment, you have to reduce the TiO2 as well. But when you keep reducing the pigment and color, beyond thickness, you cannot judge that. But when you go beyond a film thickness, then you'll be able to see the difference. That's what is my concern. Can you just answer this?
So basically, you're saying in moldings and things like that, it may not be more applicable as in a film?
Sorry?
You're saying in thicker films, we might not see this, is what you're saying?
Yes. So when you have, say, 3 mm thickness, then it is, this will be the case. Yes, of course. But when it is 20 micron film, this won't be the case. You will reduce the strength of the film, the color strength of the film, when it is 20 micron. So the more you dilute it, rather, if you want to, put the, see the same difference in 3 mm thickness sheet, then you'll have to reduce the color concentration substantially. Then you will be able to see that.
I think at the end of the day, it's always going to be, and we sell a massive amount of FP into the paint industry. Okay, the product is basically the same, but the application is different. But the optical the optical performance, the optical results are basically the same.
True.
And what we find there is that the different applications and the different formulations that lead to those applications need to slightly different compromises, okay? And it may well be that at thinner film, it's not 10%, it's 2%, okay? Or, you know, and we find this an awful lot because we can't be totally predictive about what other materials are there and how they're going to behave. The presence of other extenders, to be honest, have an influence on the effectiveness of FP. Sometimes they make us more effective, sometimes they space the TO2 themselves a little bit, and they make us a little bit less effective.
Yeah, in that case, but when you keep all the parameters same in both the conditions, then the difference will be only shown when you are reducing the strength of the pigment and strength of the TiO2 or this thing.
Yeah, I think the only thing I would say, though, is that if you can imagine the process you would go through for doing this, is you will first make a white, and you would, or you could even do it in a tinted color if you wanted. You would make a white, and you would reduce the amount of TiO2 you use by maybe 5, 10, 15%, replace it with FP. And you would look at the results you got for opacity, irrespective of the tint color, okay? Because we're about scattering the light, not changing the absorption. We see this as an additive effect. You notice in my presentation, we don't quantify this because we don't think we can. We don't know exactly what the customer's tinters are, what they're buying, and how effective they're being dispersed. But what will happen is, as the gentleman from Chemarc said earlier, when you have a titanium dioxide with a very high level of surface treatment, you get a lower tinting strength, which means effectively you use a little less tinter. It's exactly the same effect. If you introduce FP for opacity reasons to save some money, you will end up with a lower TiO2 tinting strength, which will result in some tinter coming out when you retint.
Yeah, kind of, yes, of course, yeah. Thanks for that. One more concern is that when we consider the cost advantage, that slide of the last couple of slides, when we consider the saving on TiO2, the term we can add on is increase in the cost of filler as well. See, in this case, of course, it's definitely, I'm very much interested to take some few trials on this. But some of the things which I'm really concerned is that when we consider the, say, for example, $1,500 of this product, vis-a-vis $2,900 cost of TiO2, at the same time, we have to consider $200 of filler. So when we consider, say, for example, 30% of TiO2 and 70% of filler, for example, I'm just giving you a rough idea, and this is the cost, then the FP product cost vis-a-vis, the combination of this. So the real saving to be judged should be considered when we have to, in the same scenario where we have TiO2, pure TiO2, and filler present in the system.
I think if you can use a $200 filler, you should use it.
No.
Okay?
No. What I'm trying to say.
What we find is that, and this, we get asked this question a lot, and you can do this experiment yourself. We've done it in our laboratories too. If you take, FP is no secret, it's 20% TiO2, it's 80% calcium carbonate. If you put into your formulation an 80-20 mix, and then compare it to FP, because that 80-20 mix, the TiO2 is not encapsulated, it is not fixed at the right distance apart to give the best optics, you won't get the best optics from your cheaper mix.
Exactly, that's
basically what we're selling. We're selling that bit of technology that just encapsulates those 4 or 5 particles of TiO2.
Great.
Everything else about our product, when we talk about the rough surface and the air in the particle, you get that with an extender. Okay?
Yeah, I'll be very much interested for some trials. Thank you. Thank you very much.
This is Thomas Schmutz again. I would like to come back to the mulch film application. So if you use FP, in a white mulch film. What is the contribution of the FP to the light stability? Will you have a positive effect or a negative effect?
You talk about mulch.
The mulch film, you know, a thin film application.
Oh, in a very thin film.
Yeah, very thin. And sometimes fillers have an antagonistic effect on the light stability. So I don't know, what is your experience?
Yeah, our experience, while we've not done any work in that specific application, I will be completely honest with you. FP, you can see from the diagrams we've given you, it's 4 particles of TO2. It's going to be 1 micron, whereas TO2 is going to be 0.25 micron. We are a bigger particle. As you go to very thin films, you will start to run into technical issues using a product that's got that big particle. And so when customers ask us, we say, by all means test it, but we're not recommending it for the very thin films. We have the same issue with high gloss gravure inks. We can work in packaging inks, in matte inks, but we just say to the customers, don't. It's not appropriate. And so we were partial replacement in the majority of applications, in all fairness. Thank you very much, everybody.